Good morning to all of you. Today's topic for my lecture is database system concepts and architecture. Before starting the database concept, we will discuss the data models. Actually, a data model is abstract model that document and organize data for communication between the functional and the technical users. It is a collection of concepts that can be used to describe the structure of a table, and the structure of a table can be described by its data type, relationship and the constraint. Means data type is what type of data is to be stored in the table. Means it can be integer data, it can be character data, it can be date type data or the long type data. Relationship means what are the relationship between two data. If there is a one name and the registration number, means what is the registration of that student, that particular student have a particular same registration number, means this is the relationship between the two datas. So data model is a collection of concepts that can be used to describe the structure of the table, and the basic operations that can be performed on the data is the retrieval and updates. Retrieval means how to access the data from the table or from the model or from where you have stored the data. Retrieve, how you accessing the data, how you are using the data. Update means to manipulate the data or to change the data. When we have to change the data, we are saying we are updating the data. Next is specifying the dynamic aspect or behavior of a database application. Means whatever you are designing, what is your database, where you are using that database. For example, you are using the database in any company, you are using the database at any mall, you are using the database at any institute. Means this is the dynamic aspect or behavior, what type of function your database is performing. For example, compute GPA means computing the gross salary for the which can be applied to the student object. Means you are calculating the GPA of the student, means marks of the student. So this application is applicable for the any institute or any educational institute. So data model is actually a protocol or a structure in which you are describing the data, you are applying the data, and it have a specific data type, specific relationship between the data, and the constraint. Constraint means condition. Constraints are the condition which you are applying on the data. Means what type of data can be inserted into the database, what type of data cannot be inserted into the data type in your database. This is the constraint. We categorize the data model into the three levels. Means we have to design the data at three levels. The very first level is high level or conceptual data model or the common user. Means when you are using the data, or any non-technical person can also use the data. What you are seeing the final output, the presentation view. This is the conceptual data model. Next is the low level or physical data model. Physical data model means it describes how actually data is stored in the database in the binary language. And in between the high level and the low level language, there is a one concept, there is a one level which represents the, which serve both the categories, both the high level language and the low level language. This is called the logical level, which makes the things possible, which convert the concept into the technology. This is known as the logical level. So very first is conceptual data model. Conceptual level is actually a presentational level which actually uses with what the actual user is seeing. Actually what the actual user is seeing is the conceptual level. When we are running any application, we are executing any application, it is at the conceptual level. Means when we run the application, this is the conceptual data model. For example, entities, a real world object or a concept. Concept is if I am taking example of any student, then department or course, means a student is studying in which department, in which course. This is one entity. Department is an entity, course is an entity. Attribute, it is a property of interest that further describe the entity, means when we give one heading to the entities. So name, various names and inserted in one column, and we said it is one attribute, and the name of we naming the attribute as name. When we save all the telephone numbers in one column, we said it is a telephone attribute. When we inserted all the departments in one column, we said it is a department number. So this is the attribute. When we give one heading to the entities, we said it is the attribute. If you are reminding a table in your head, then when the data is stored in the table, it is entities. When a particular type of entities, a column head is known as attribute. And what is the relationship between the entities, means one particular student is studying in particular department having the particular course, means this is the relation between the department and the course, means which department is running which course. This is what at executed at the conceptual data model. So I am summarizing, conceptual data model is dealing with the entities. Entities is any noun. When you say a noun, a object, a single word, this is the entity, a real world object. It can be department, it can be student, it can be course. Attribute, that describe the properties of entities. One type, when we describing the properties of entities, we said it is an attribute, and we put one type of entities in one column. This is the attribute. And the relationship, what the two attributes have a relationship between them. This is all done at a conceptual data model. Now the physical data model. Physical data model describe how data is stored in the computer. As we all know, in the computer, data is stored in the form of binary languages. So at a physical level, there is zeros and ones. It represent info such as what are the record format we are using, what is the record ordering, how the access path makes search more efficient. Actually, this physical data model is dealing with indexing, hashing, means indexing means where the data is present. Index actually as a book index, what maintain what data is present at what page number. In the same way, we have a concept of indexing, which is done at a physical model, what data is present at where place. So this is the work of the physical data model, to arrange the data into the memory, to take care what is record format we are using, at what order the data is being used. Now representational data model. Actually, data model is categorized into the three types. The one is relational data model, network model, and the hierarchical model. Relational data model includes relation variable. Relation variable means name of the table. Relational data model in which data is present in the form of table. Relation is set to the table. The other name of a table is relation. So when we store the data in the form of table, we said it is a relational data model, and the relation variable is name of the table or name of the variable. Then we have the attribute. Attribute is name of the column. Column head is known as the attribute. When we put one type of data in one single column, we said it is a attribute. And the other variable we used in the relational data model is entity, a single noun, any object, any real world entity. We describe it as a entity, and the combination of entities attribute is known as relational data model. Next is Network model. In the network model, data is organized into the record and sets. We have so many records, and these records are connected to other records, and we have a key path, means depending upon one particular key we can search the other data. Depending upon the relation between the two entities, we can go for the next. In the hierarchical model, data is organized into the tree-like structure, implying a single upward link in each record to describe the nesting of the data. Means we have one level up above the one entity, one level up above the other entity. Means we have a one root node, a further the two childs, a further of four childs. For example, in any institution where we have one principal at the top of a hierarchy, then we have HODs after the hierarchy, then we have a lecturers after the hierarchy, then we have a student. So this is the hierarchical model. When we are following one particular hierarchy, this is the hierarchical model. Now comes the schema. Schema, what you understand from the schema? Is the description of the database? No. Schema is the overall structure of the database. It specifies during the design. Means when we are designing the database, we are setting this is the schema. It's not expected to change frequently. Means once we design the database, we cannot frequently change it so quickly. It's not an easy job. It display schema is known as the display schema, means whatever the structure of the table, whatever the columns you have added into the table, this is the database schema. For example, each object in the schema such as student or course is a schema structure. Here you can see the diagram. Here we have a four tables. The one is student table. Student table have four attributes: name attribute, student number is attribute, class is attribute, major is attribute. Means a relation student, relation variable is student, attribute we have four attributes having the value name, student number, class and major. So this is the schema of the student, design of the student. In the same way, we have a course, course name, course number, credit hours and department. These are the four attributes for the relation course. So this is the schema of the course table or course relation. Then we have pre-request. Pre-request means how many applications for which course. So we have two columns, two attributes, course number, pre-requesting number. In the same way, we have section, we have grade report. So this is the schema of a particular relation. Student have a four attributes, course have a four attributes, pre-request have two, section have a five and the grade report have 3. This is the schema, means structure of the table. So I am repeating, it does not specifying the description of database, but it specifies the database design. Once the schema is designed, it should not be frequently changed, means because it is a difficult job to change the schema of the table. And we describe this schema into the next diagram. Schema diagram represent only some aspects of the schema. So this is the schema's example. Next term we are discussing is instances and database site. Instance, what is instance? As the name implies, the data in the database at a particular moment in time is called a database state or a snapshot. At one particular time, what type of data or what data is stored in your database or in your relation is known as the one instance of the database. When you change the entities in the data, the instance of the database is also changed. This instance of the database is also known as the current set of occurrences or the instances of the database. So I am repeating, at a one particular time, what data is stored in the database is known as instance of the database or the snapshot of the database. When we define a new database, we have database state or a empty state. Schema specified only in the DBMS. Schema is different. Schema define the overall structure, instance define what the content is stored in the table. So initial state is empty. When you only describe the schema, the initial state is empty, and when you insert the content, the data into your table, then we have the instance of the database. So first, when you describe the schema, your initial state is empty. When you insert some values, suppose you have insert 5 values, this is the instance of the database, and when you insert 5 another value to your table, then it have 10 records, this is the one another instance of the database. Then at any point in time, the database has a current state. Schema can be evaluated when we need to change the schema, means we can change the schema, but it is a lightly a difficult task and it should not be changed frequently. Next is the 3-tier architecture. So first of all, we should know what is the importance of this database approach. Insulation of program and data means, insulation means how you can different the program and the data, how you insulate the program and the data, means when you are organizing any data through the programs, we said we are insulating the data. This 3-tier architecture helps to support the multiple user view. Multiple user view is what? View is one snapshot of the data according to the user requirement. Suppose I have 7 attributes in my relation, but at some time I want to see only the 3 of the attribute and the rest of the attribute is not a helpful data for me. I can put a query and I can run the relation for only 3 attributes. This is called one view of the table. And suppose at the same time one another person need those which I have left, another person need only for those attributes. So then he will continue for those view. So this is the approach of a database. It can help to activate the multiple views, means one user can view according to their requirement, other can use according to his requirement, etc. Then the use of catalog to store the database description. It is, as we all know, catalog means it describes where to store the data or any mark, so that we can easily recognize where the database is stored or where the database is, what is the description of the database. This is all what the 3-tier architecture can do for us. And the aim of this 3-tier architecture is to separate the user application and the physical database. Means to make we have 3 levels. The one is physical level, above is logical level, and at the top is conceptual level. At a physical level, actually the data is stored, and at a conceptual level, what user is seeing logically. This is the two different, and the aim of this 3-tier architecture is to make compatibility and to take these two things separately. What is the application, and conceptual level does not care how the data is stored in the database, and the physical level does not care how the application is visible to the program user. Schema can be defined at a 3 level, as we already discussed. The internal level, internal schema, this describes the physical storage structure of the database and it uses the physical data model. So the first schema can be stored at a internal schema or a internal level. It is using the physical storage structure, means how data is stored in the database, how indexing is done, how optimal space utilization is done. Optimal space utilization means which data is stored at which space, how the space can be evaluated so that the correct or efficient data or exactly what data can be present and exactly where this actually the space is required or present. This is the diagrammatically view of three-tier architecture in which data is or a view are divided into the three levels. The very first, as you can see, the internal level. This is also called the physical level. This internal level or internal schema is connected with the database storage, means actually where your data is stored, it deals with the physical schema, how bits are arranged in the database, how optimally it is executed, how optimally it can be retrieved. This is all what will be done at a internal schema level. This is using this internal schema using the physical data model for having its data. Next is the conceptual schema. Conceptual schema is the is telling the logical behavior of the table, means after coming to the bits and bytes, when we describe the data into the entities, relationships and the attributes. This is the what the conceptual schema means, how relation is maintained. Relation means table. Here I am asking relation for the table. How data is stored in the table, this is the relation. So relational is taken care at a conceptual schema. It is taking care of entities, attributes and the relationship. I am repeating, entity is a common object, a real object. We said it is a entity. When we describe the one type of entities into a one single column, this is known as attribute. A column head is known as attribute. Suppose we have Gagan, we have Magan, we have Ram, we have Sham. This particular type of entities we set into a table as a attribute name. We have a roll number of so many students, we organize the roll number in one column and we said it is a roll number name. This is what at a conceptual level. Then come the external view, means how we are seeing the application, how we are actually running the application. And the conceptual schema is making the relation between the external view and the internal view, and with the making relation it also separate these two. And to make the communication between the external view and the conceptual schema, we have a external conceptual mapping. And to communicate with the conceptual schema and the internal schema, we have the conceptual internal mapping. Now, the conceptual level has a conceptual schema describing the structure of a whole database for a community of user. Means at a final stage at a computer, what we are seeing, the concept describing the structure of whole database for a community of user. It hides the detail of physical storage structure. It does not care how bits bytes are stored in your computer. It only deals with how user is seeing the data and concentrate on describing entities. What are the data types of entities, means whether it is an integer type, whether it is a character type, whether it is a varchar type, whether it is a date type, and what is the relationship between your entities, and what are the user operations you are applying, whether you are updating the data, whether you are retrieving the data, whether you are using the data, modifying the data, and what are the constraint you have applying. Constraint means suppose you any unauthorized person trying to insert data into your table, there is a constraint, only an authorized person can insert data into your table. And Constraint means conditions, sharta. What are the conditions at which the data can be inserted or used in your table? A high level data model or an implementation data model can be used at this level. The external or a view level includes a number of external schema or user view. Number of means a different user have different requirement. When the different user have different requirement, this three-tier architecture helps to view a number of external schema or user views describing the part of a database that a particular user group is interested in and hide the rest of the database from the user group. Means one user, suppose as I told before, suppose there is a table of 7 attribute, one user want to see first 3 attribute and the other use want to see other 4 attributes. This three-tier architecture helps to make the two different view in which one the 3 attributes can be seen and in the other 4 attributes can be seen. A high level data model or an implementation data model can be used in this three-tier architecture. Next, the concept of data independence. What is the data independence? Independence means it is the capacity to change the schema at one level of a database system without having to change the schema at the next higher level. Suppose here you see, when we have to change some at external level and we want the data should not change at a conceptual level, when we can change at external level without affecting the conceptual level, this is called physical independence. Logical and we have two types of independence. Capacity to change the conceptual schema without having to change the external schema or the application program. And the physical data independence is capacity to change the internal schema without having to change the conceptual schema. This is known as data independence. Here you can see this is the external view and this is the internal schema. When we have to change in this internal schema without changing this external schema, this is known as physical data independence. And when we have to change this external schema without affecting this physical or internal schema, this is known as logical data independence. Means ability to change at one level without affecting the other level. This is known as data independence. And when we have to change the logical data without affecting the physical level, this is known as logical data independence. And when we have to change the internal schema or the physical data, how data is actually stored, and without affecting its appearance, without affecting its presentation at a conceptual level, this is known as data independence. Now, to deal with data means we can change the data, we can update the data. This is the one of the facility of the database, that we can change data, we can update data. But how? How we can change the data? This can be done using the languages, using the queries we have, using the commands we have, and these queries, commands can be categorized into the different languages. For that we have 4 type of languages. The very first is data definition language. We said DDL.